Agentic AI in metal additive manufacturing, from concept to controlled integration. Last week, AI Build's chief executive, Dagan Kam, hinted at a step change for AI in manufacturing. He hinted that the familiar AI Build workflow automation engine would soon be accessible from a range of leading LLMs, like Grok or Claude, and linking directly to enterprise knowledge bases to drive automated manufacturing processes. For experienced teams in metal additive manufacturing, this is more than a product update. It reflects a broader industry move towards agentic AI. AI systems embedded within operational environments, able to act across enterprise platforms with defined permissions and auditability. In AM, where build times are long, compliance is strict, and the cost of a single reprint can be significant, these capabilities could transform how design, production, and quality functions work together. This isn't about replacing expertise. It's about orchestrating the flow of data, checks, and decisions so engineers spend less time on manual administration and more on engineering. Before we look at where agentic AI fits into AM workflows, it's worth clarifying the distinction between the large language models most of us are familiar with and this next stage of capability. Most AM leaders have used LLMs for summarizing reports, extracting data, or cross-referencing technical documents. But LLMs remain essentially advisory tools. They provide information on request. Agentic AI, by contrast, is embedded into the operational environment. It can connect directly to MES, PLM, QMS, or ERP systems, execute pre-approved actions, and log every step for compliance. Imagine the difference. A conventional LLM can find last quarter's Alloy 718 build data from an MS export. An agentic AI can go further, query the MS in real time, check each build against the latest PLM material spec, flag deviations, update the QMS record, and notify the quality lead, all as part of a governed, auditable workflow. For Metal AM, that shift is game-changing. From there, we can extend the idea into what's often referred to as physical AI, systems where the AI's scope reaches beyond data into the physical process itself. This might mean triggering a powder hopper purge when sensors detect out-of-spec humidity, adjusting ricotta speed mid-build based on layer quality, or pausing a print when melt pool data signals a potential defect. The AI is not acting independently, it is executing predefined, permissioned actions, but doing so in real time and with no manual delay. For AM leaders, this represents the bridge between digital decision support and true closed-loop control. Closely linked is the concept of industrial AI, not a generic AI dropped into a factory, but AI built for industrial realities. That means resilience to imperfect data, security-hardened integration, uptime reliability, and compliance with standards like AS9100 or ISO 13485. In AM, an industrial AI could automatically adjust part orientation in slicing software based on distortion trends, update the PLM, and alert quality control without breaking the compliance chain. It is about embedding intelligence without disrupting the processes and certifications that underpin your production. Underlying all of this is the question of integration, and here the Model Context Protocol, MCP, is emerging as a universal interface standard. Instead of bespoke, brittle integrations, MCP allows AI agents to discover available tools and data, request permissions, and execute actions securely across MES, PLM, QMS, ERP, sensor networks, and even machine controls. For AM teams, it's a way to make AI integration repeatable, auditable, and faster to deploy. So where does AI actually fit into the AM workflow today? Right now, most deployments are in advisory and administrative tasks, summarizing build logs, retrieving historical runs, drafting customer compliance responses. But the trajectory is clear. In the near term, we'll see pre-build CAD validation, automated parameter configuration, and in-build defect prediction becoming mainstream. Post-build AI will automatically collate inspection results, generate compliance reports, and update traceability records. Each of these moves from information support to action support, with increasing efficiency gains and rising integration demands. That said, it's not without its hazards. In early trials, we've seen integration failures between modern MES and legacy controllers, compliance breaches from overwritten QMS data, false positives from poorly trained defect detection, and over-automation in unstable workflows. These aren't reasons to hold back, but they are reasons to proceed methodically. Validate in isolation, prove in controlled environments, then integrate into full production. If we look ahead, the development curve will not be linear. In the next 1 to 2 years, expect AI to remain in a supervisory role, read, analyze, alert, with MCP providing the interoperability backbone. Within 3 to 5 years, governance frameworks should allow limited closed-loop control in targeted workflows, such as pre-approved parameter tweaks or automated sequencing of hybrid AM, subtractive operations. Beyond 5 years, we may see AI orchestrating full manufacturing cells, blending additive, subtractive, inspection, and finishing in a seamless flow. For AM leaders, the priority is not guessing exact dates, but ensuring your organization is ready to adopt as soon as these capabilities are proven, certifiable, and commercially sound. Recognizing the potential is one thing, realizing it is another. Integration, governance, and a structured path from pilot to production are essential, and most AM organizations won't go it alone. Large OEMs often work with specialist partners for MCP integration and compliance validation. Smaller firms rely on integrators to bridge the gap between strategy and operational reality. Whether you're building capability in-house or working with a partner, the team at additive.ai can help design and execute AI-enabled workflows that improve yield, shorten lead times, and maintain compliance. The time to prepare is now, before the early movers lock in the standards and best practices. Those who act today will set the benchmarks others follow tomorrow.